Okay, hi everyone. So let's start our 13th recitation of this semester. So it's been a while since we did this live. First we had the elections and then the quiz. So I think it's been 3 weeks. So it's nice um, to kind of see you all again after 3 weeks. So today is basically we'll do a review of combinatorics for the most part in preparation for quiz 5, and I'll talk a little bit more about that. I have a bunch of quick announcements. So we posted the quiz 4 grades. So you can see that now on Gradescope and on Canvas. As usual, you have 1 week, meaning until November 24th, to file a regrade request on Gradescope. So please do that sooner rather than later if you want your quiz to be regraded. And then we solved what we thought were the hardest problems from quiz 4 during discussions last week. We did not post anything on Piazza, but we solved the hardest problems during discussions. So if you are curious about solutions for quiz 4, you can watch last week's discussions. If you're curious about the problem that we didn't cover, please message us or come to office hours and we'll help you out. And so we'll do the same thing for quiz 5. So we always solve in the discussions after the quiz a couple of problems. And then quiz 5 is next week. So this will be November 24th, and it'll be, as usual, 1 hour. However, this time it's between 7:30 a.m. and 5 p.m. So we extended the window a little bit. So you can start at 4 p.m. and still be able to submit in time. And this quiz 5 will be on counting and probabilities. And we'll do plenty of reviews of this material before the quiz. So we'll review counting today. On Thursday, we'll mostly focus on reviewing probabilities during discussions. And then on Monday, there will be kind of a last-minute quiz review session similar to the one we did before quiz 4. So there'll be plenty of opportunities to study this material and to review it. And unfortunately, we're a little bit behind with grading. Homework 5 and quiz 4 were due around the same time. And so it was really hard to grade both. But we hope that we'll be done with grading of homework 5 by Friday, so that you'll have time to see what you did wrong and so on and still study before the quiz. Okay. As usual, when we post the grades, we also post this histogram. I mean, what can I say? It looks really good. The class did really well on quiz 4, as this scores reflect. Final quick note, if you want to ask questions, you can either ask them in chat, and our TA Lynn is keeping an eye on those questions, or feel free to just unmute yourself and just speak up and ask the questions like that. That's totally fine and encouraged as well. Okay, so these were my announcements. So before we start, any questions about quizzes, course, structure, anything like that? One thing I kind of forgot, but I guess it's hard to keep reminding you about that. So, there is a final exam in this course. The exact time is in the syllabus. I forgot when it is, sometime in early December. One thing to keep in mind about the final, it won't be a sliding window like what we do with quizzes. So you will only have the time available that is actually, prescribed by the university in the university calendar and outlined in our syllabus. So you have to be able to take the final during that time. It won't be offered outside of that time. So that's something to keep your eyes on. And I suggest, as soon as we're done with this recitation, go ahead, take a look when it is, put in your calendar, make sure you are available during that time, and so on. Okay, so let's start working on our problems. We'll start with a few simpler ones, and then we'll do a few what I would consider harder ones. After every problem, I'll give you a couple of minutes to try to solve it, and then I'll solve it for you guys, and I'll take any questions you might have. So here's the first one. It should be a really easy one. So at the wedding, there are 4 appetizer choices, 5 entree choices, and 3 dessert choices. And the question is, how many different choices are there for a guest to select a meal? So I'll give you maybe 2 minutes to try to solve it, and then we'll do it together. So please go ahead and give it a try. With every question, I'll just kind of quickly note whether I consider it easy or hard, just so that you engage how the quiz will look like. And so this question I would consider to be super easy. Like you should be able to solve this in like 2 minutes. Okay, so the solution for this one is, we have 4 choices for the appetizer times 5 choices for the main course times 3 choices for dessert, and that is 60. So there is 60 total choices for the meal. Any questions? Okay. There was a good qualification question. Does the guest choose one from each of them or just one from any of them? Well, now I already revealed what the answer is. So the guest chooses one from each. So the guest has to assemble a meal where the guest chooses one appetizer, one entree, and one dessert. Any other questions? Okay, let's move on to the next problem. I'll skip this one, and we'll do a bunch of problems on permutations and combinations. So a quick reminder, permutations are a structure where the order matters, but you don't allow repetitions. And you denote them with P of n comma k, where n is the number of elements in the set that you are kind of taking from, and k is the length of your sequence. And you calculate them using this expression. Combinations are structures where there are no repetitions, but the order does matter. So that's the difference between combinations and permutations. We denote them with C of n comma k, and this is how we calculate them. So whenever we see a problem, we have to determine which structure are we applying. And we determine that by establishing whether the order matters in the structures we are creating and whether there are repetitions. So after we answer these two, then we know which structure we have to apply. Okay, so let's try to solve a couple of problems using these concepts. So here's the first one. Again, another really easy one. So 10 kids are getting in line to buy ice cream. How many ways are there to form this line? So I'll give you 2 minutes to try to solve this, and then we'll do it together. Okay. So this is simple. It's P of 10, comma 10. And then if we want to calculate this out or clean it up a little bit, we get 10 factorial. And there is a corner case. I want to show 10 minus 10 factorial. And that is equal to 10 factorial divided by 0 factorial. So at this point, this might look kind of weird. Like, whoa, we have division by 0 here. How do I calculate this out? This is weird. And you have to remember the definition, according to the definition of factorials, 0 factorials is equal to 1, not 0. So that is actually equal to then 10 factorial. Okay, any questions about this one? Okay, so this is another easy question. Like you should be able to solve a question like this in like a minute or two. On the quiz, we are not going to ask you to calculate final solutions if the numbers are gigantic. So something like this, 10 factorial, we're not going to ask you to calculate it out. If the numbers are smaller, let's say under 1,000, we'll ask for the final count. And in the quiz, we'll actually specify that. We'll tell you alongside the question, are we looking for the final count or not? So basically, you don't have to worry about having to calculate, gigantic numbers and so on, since we don't allow calculators anyways. Okay. Okay, another question. We want to select a subset of 5 people from the set of 18 junior students and a subset of 7 from the set of 16 junior students to form a committee. How many ways are there to form such a committee? So, the committee has 12 people total. 5 we are selecting from junior. 5 we are selecting from 18 junior, 7 from 16 senior. So again, I'll give you maybe 2-3 minutes to solve this, and then we'll do it together. If you ever have any kind of clarification questions about the problem, feel free to ask them even before I solve it. Okay. So how do we do this one? So first, we choose out of 18 junior people, 5 of them to fill in these 5 junior positions on a committee. And then times, we're choosing out of 16 seniors, 7 of them to fill in the 7 senior positions. So that is the solution. We're using rule of product here because we're assembling these committees. So there is an end between them. Any questions about this one? Okay, so there is a question. How do we know when to add and when to multiply? So I feel this question comes up a lot. So let me try to kind of clarify this. We'll have a question where you have to add as well. So, you have to multiply when you are assembling your final structure from several pieces. So here we are trying to assemble this committee of 12 people from 5 junior students and 7 senior students. So there's this keyword "and" here, and we are assembling this final structure from these different pieces. So then to get the final number, you have to multiply these counts. You use addition when you have to do a union of counts of already finished structures. So the keyword you're looking for there is "or." So an example, I could make this question a little bit harder if I would say we want to select a subset of 5 junior students from 18 and 7 senior students from 16, or let's say, or 8 junior students from 18 and 4 senior students from 16. So then the solution for this question that I just created on the fly would be plus choose 18,8 times choose 16,4. Sorry. So, we are assembling these 2 types of committees, and because the final count is one or the other, you would have plus in between them. So that was a good question. It came up a couple of times before, and I hope this helped to clarify it. Okay, let's move on. Okay, so the next question is, how many license plates that contain only numbers or digits consist of 6 digits from 0 to 9 with exactly 2 of the same digit? So there are 6 digits total, and exactly 2 of these 6 have to be the same digit. And we've seen examples of questions like this before. So you're filling in these digits, and it's a common pattern that appears over and over again. So why don't you try to solve it? Again, this one is a little bit harder. So maybe I'll give you 3 to 4 minutes. I think it's kind of a step up from the previous 3. By the way, feel free to post your solutions in chat. I will not have time, and I encourage you to do that. You don't have to be shy about it. Some of them might be wrong, some of them might be correct. It's totally fine. It's actually kind of nice if you kind of keep doing that, because I can kind of go over them, and sometimes I can spot some common mistakes and so on. And so I can comment on them a little bit. I won't have time to comment on all of them, but if I spot, an interesting pattern, what I think might be a common mistake, then it will help me to kind of catch it and clarify it. Thanks for posting. There are some interesting ones there, and I'll definitely comment on some of them. So Brady, you are really close. You have to do kind of one small change, or maybe two. Okay, so let me try to solve this, and then I'll come back to the chat and maybe comment on that a little bit. So we've seen problems of these kinds before. The one part of it is kind of similar. We had this thing like the word Mississippi and how many different words can you create from it, right? So this problem is a little bit related to that. So the way to think about this is we have these 6 slots that constitute our license plate. So 1, 2, 3, 4, 5, 6. And the algorithm here is, first, we pick 2 slots out of the 6 in which we are going to place these 2 digits that have to be the same. And then once we do that, we fill the other 4 slots with the leftover digits. And we have to be careful that we don't repeat the digits in the leftover 4 slots. If you repeat the digits there, then you are going to have maybe more than 2 of the same digits, or you're going to have 2 pairs of the same digits, right, and so on. So that's the algorithm. So now how do we do this? So first we are going to choose 2 slots out of 6 where we are going to place these digits that should be the same. So this chooses the slots. Now, how many different digits can we place in these 2 slots? Well, any of the 10 digits. Okay, and now we still have to deal with 4 leftover slots. And those are just going to be permutations of 9, 4. So it's the same as removing these 2 slots that we filled in. And then we have a sequence of 4 slots. We are filling them with 9 leftover digits, right? We cannot reuse the digit that we used to fill in the 2 slots, right? We cannot do this, Let's say we choose 2 and 5, we fill it up with 1. Well, we cannot put 1 at place 4 because then we have more than 2 of the same digit, right? So we can place any of the other digits, let's say 0. And it's permutations because repetitions are not allowed. You cannot place another 0 here because then you have, more than exactly 2 of the same digits. So that's kind of the line of thinking, and this is the solution. Any questions about this? Let me take a look at the chat a little bit. so some of the solutions, or at least one, has, 9 to the power of 4 as a component instead of permutations. So that's not right because you are allowing repetitions. So if you do this, it means for the 4 leftover digits, you can do this, right? And that means that you will have, more than exactly 2 of the same digit possible, right? You can have 4, right? Then, I've seen solutions something like 9 square times p 9,4. So this 9 square, for example, allows that you do allows that these two digits don't have to match, and so on. Okay, I can't really comment on all of them, but these are maybe some common kind of mistakes. Any other questions about this problem? And thanks for posting your solutions. So how would I rate this on the quiz? I would say this is, let's say, a medium hard problem. Yeah, maybe a little bit more than medium, because I think it's a little bit tricky, but it doesn't involve a lot of computations. Okay, so let's do the next one. Okay. So the next question is, how many possible sequences of 10 coin flips give exactly 3 or exactly 4 heads? First of all, notice this or here. We talked about that. Second of all, this problem is kind of similar to, it shares some commonalities with the previous problem, right? You're filling the sequences and you need exactly 3 or exactly 4. So I'll give you a couple of minutes to try this on your own. Feel free to post your solutions as before, and then we'll do it together. Oh, one more side note. Please calculate the final number. Using pen and paper. You should know how to do these calculations using pen and paper. Usually lots of things cancel and it's easy to multiply for this problem. You can also post the final number that you get in the chat. So is anybody done? If you're done, post your number. If not, then maybe I'll give you another minute. Oh, okay. So I'll wait another minute and then I'll solve it. Great. Hey, it's nice to see good solutions. Okay, so let's do it. So same as before, right? This time we have 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so what is the algorithm? So first we have to put exactly 3 heads, right? So we're going to choose 3 slots out of this 10. We're going to put heads in these 3 slots, let's say here, here, and here. And then we're going to put tails in the leftover slots. And the similar thing works for exactly 4 heads. So it's going to be, we're choosing out of 10 positions 3 into which we're going to put heads. We put tails in others. So they're just, times 1. And then plus, we are choosing, out of 10 slots, we are choosing 4. Okay, so there's a solution, and you can calculate this out. So it's going to be 10 factorial divided by 3 factorial times 7 factorial plus 10 factorial divided by 4 factorial times 6 factorial. So 7 cancels out with 10 factorial, and what is left is 10 times 9 times 8 divided by 3 times 2 plus 1 times 6 factorial cancels. You get 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. Here is plus. And that is equal to, more things cancel. 2 cancels with 8, you have 4 here. 3 cancels with 9, you have 3. 4 and 2 cancel with 8. 3 cancels with 9, you have 3. So that's equal to 120 plus 210, and that is equal to 330. So that's the solution to this one. So learn how to calculate out these things. And usually lots of things cancel, so it's not hard. And good job, everybody who got it. So I would say that's kind of a medium hard quiz problem. Any other questions about this one? That's an example where you have to use rule of sums. And like I said, or is the keyword to look for. Okay. If there are no other questions, let's do one in a breakout room. So I cannot, you won't see the slide in the breakout room, right? That's the problem we had before. So just write down the main kind of key points of the problem. So you're tracking a baseball player, you're writing their performance on 10 successive plate appearances. So it means you have order list of length 10. And for each plate appearance, you write down H for hit, S for strikeout, and B for base on balls, and O for other. So you have, letters H, S, B, and O. You're putting them in a sequence of 10, and repetitions are allowed, right? And now the questions are, how many results are possible? Of all possible results, how many have exactly 3 H's? And the final one, exactly 4 H's, 1 S, 2 B's, and 3 O's. So let me do breakout rooms, and you guys can discuss it there, solve all 3, and then we'll do it together. Okay. Okay, welcome back everybody. And sorry, I kind of messed up the number of rooms a little bit. It's okay. Could have been worse. Okay, so let's quickly go through this. So how many results are possible total? It's going to be 4 to the power of 10. So, you're filling in the sequence of 10 and repetitions are allowed here. Okay. So now, how many have exactly 3 H's? So we've seen these kinds of problems. So you choose out of 10 spots total, you choose 3 for H's. And then you have to fill the rest of the slots with the leftover letters times, 3 to the power of 7. Because you have 3 letters left and 7 spots. And then the last one, that's a similar one to that Mississippi problem, right? So what is the algorithm? You first picks 4 spots out of 10 for 4 H's, then pick 1 spot out of the leftover spots, so 6 of them for S, and then leftover for 2 B's and leftover for 3 O's. So how do we pick 4 H's? So let's choose 4 out of 10 times. Now we are picking 1 for S. So it's going to be 6, 1. Then we are picking 2 for B's. So 5, 2. And we are picking 3 for O's. So there's the solution to the last one. One thing to note about the last one, the order, how you place them doesn't matter. So what I wrote down, I was just following the order here. Clearly, if I went, let's say, first I place the S, exactly 1 S. And let's say then I place 2 B's. So 9, 2. And let's say then I placed 4 H's. Wait, I messed something up. 3, 2, 10, 1. Oh, yeah, sorry. So out of 7, we choose 4. And then times, again, 3 O's, 3, 3. So these two are going to be the same. So the order doesn't matter. Any questions about this? Okay. Maybe we have time then for one more. Let me do this one. Let's try to quickly do one more. This is from the homework. I think let's do this one. So you have 2 minutes left. So a bag consists of 8 apples, 4 bananas, 7 pineapples, and 5 pears. We're going to fill a box with 3 pieces of fruit from this bag. It's a little bit confusing because it's not really a bag problem. So you're filling this box out of a bag, right? But be careful a little bit here. So how many ways we can fill this box? Such that there are at least 2 types of fruit in the bag. And then assume that fruits are distinguishable. From these 8 apples, we distinguish each apple in these 8. And as a hint, I think the simplest way to calculate this is you calculate the total number of ways to fill in this box without taking this this constraint into consideration that you need at least 2 types of food in the bag. And then from the total number, you subtract the number of boxes that have only 1 type of fruit. If that makes sense. So we don't have a lot of time, so I'll give you maybe 1-2 minutes to try to solve it, and then I'll quickly do it for you. Okay, so I'm running out of time, and I'll even have to go a little bit over time, so I'll try to do it quickly. So what is the total number of boxes or different boxes we can fill in without taking this constraint into consideration? Well, we have a total of 8 plus 4 plus 7 plus 5, that is equal to 24 pieces of fruit, and we're choosing 3 out of this 24. So choose 24,3 is the total number of different boxes we can generate. And now I want to calculate the number of boxes that have only one type of fruit in them. So what is the algorithm here? Where either I'm going to choose only 3 apples, so that's going to be choose 8,3, or I'm going to choose 3 bananas out of 4, so it's going to be choose 4, 3, or I'm going to choose 3 pineapples, or I'm going to choose 3 pears. So when you add all this up, you get the number of boxes that are filled with only one type of fruit. So then if I want to calculate the number of boxes that have at least 2 types of fruits, I have to subtract this whole thing from this. So it's going to be choose 3 from 24 minus this whole thing. I wouldn't ask you here to calculate it out because the number is, let's say, greater than 1,000, but it ends up being 1919. And so I'll have to stop here because Professor Phillips has to start her session. Hey, good job, Isaac. Great.
Thanks.
Yes, good question, saying distinguishable mean that these 8 apples are all different from each other. So it's not the same which 3 apples you put in, right? If they're the same, it would actually be a much easier solution. So that's a good question. Any other quick questions? Okay. If not, then thank you all for joining. This was fun. Make sure to understand all these questions. The last 2 or 3, I mean, that's the kind of hardness you can expect on the quiz. Some of them will be even a little bit harder than that. So if you're struggling with these, then, come to office hours. There is still plenty of office hours available before the quiz. Okay, thank you, everyone.